Hi everyone, this is lesson 2-3, the remainder and factor theorem. In this last video, we are going to be able to use remainder theorem to evaluate polynomial functions and the factor theorem to factor polynomial functions. Alright everyone, we're going to be talking about the remainder theorem here. And the remainder theorem is if a polynomial function, f of x, is divided by x minus c, then what we get is the remainder, r, is equal to f evaluated at c. So if you remember earlier in the year, we talked about evaluating the function. For instance, I might give you the function f of x equals x squared plus 4x minus 1. And we can evaluate that function, let's say, at x equals 4. I might ask you, what is f of 4? In which case, in the past, we have substituted 4 for x and then evaluated the function. So 4 squared is 4 times 4, which is 16. Here, 4 times 4 is also 16. And then we subtract 1 at the end. 16 plus 16 is 32, minus 1 gives me 31. So one way to evaluate a function is the way that I just showed here, but we can also use polynomial division or synthetic division in order to figure out what the remainder is, in which case the remainder tells us what f of c is. Now remember, c here is going to be our 0 for our divisor. If I took x minus c and set it equal to 0, then I get x equals c. So if I wanted to take this polynomial function right here, f of x, and I wanted to evaluate it at the x value of 4, another way I could do that is by using 4 as my divisor, right? 4 is my divisor. And if I use my coefficients of my polynomial function, 1, 4, and negative 1, 1, 4, negative 1, and if I carry out synthetic division, I already know what my remainder is going to be. It's going to be 31. So if I carry down the 1 times 4 gives me positive 4. 4 plus 4 is 8. 8 times our divisor of 4 is going to be 32. And when I add this column 32 and negative 1, I get 31. So what this means is that f, the function f, evaluated at 4, which is our divisor, is equal to our remainder, which is, not 32, my bad. I meant to say 31. 31. So again, earlier in the year, we learned to evaluate functions by substitution. Here, we're just layering it on top of our discussion of synthetic division, in that synthetic division can be used as a method for evaluating a function. So what we're going to do is we're going to look at an example here. It says, suppose 800 units of a beachfront property have tenants paying $600 per week. 800 units, $600 per week. I'm underlining the key information here. Research indicates that for each $10 decrease in rent, 15 more units would be rented. The weekly revenue from the rentals is given by the function r of x, where x is the number of $10 decreases the property manager is willing to take. Use the remainder theorem to find the revenue from the properties if the property manager decreases the rent by $50. Okay, there's a lot of information here, and we gotta kind of sift through what we actually need to use. So first of all, they want us to find. They want us to use the remainder theorem to find the revenue from the properties if the property manager decreases the rent by $50. Okay, so if we go back up here where it says research indicates that for each $10 decrease in rent, 15 more units would be rented. So, if we decrease this by $50, if we decrease the rent by $50, we have to figure out how many $10 decreases that equals. So, if you divide $50 by $10, that equals 5 $10 decreases, because 10 goes into 55 times. So what we're going to do is we are going to then use that 5 as our divisor, okay, because this is the number of, where X is the number of $10 decreases the property manager is willing to take. Remember, if we're decreasing rent by $50, that's 5 $10 decreases. So we're going to use 5 as our divisor, and then we're going to take that and use the revenue function to figure out how much revenue then the property manager would create by decreasing the rent by $50. So, we are going to use our coefficients in our revenue function, which is negative 150, 1,000, and 480,000. And if I carry out my synthetic division here, I'm going to carry down the negative 150. When I multiply negative 150 times 5, that gives me negative 750. And when I add my columns here for synthetic division, 1,000 minus 750 is 250. And if I take 250 and multiply it by my divisor of 5, I get 1,250. And when I add those columns, then I get 400. I'm running out of room here. I get $481,250. So this is the amount of revenue. This is the amount of revenue that the property manager would generate if he dropped rent by $50. And what happens is, and you might be thinking, well, if he drops rent by $50, isn't he going to be making less money? But you have to remember in the beginning, by him dropping the rent, it makes it more affordable to people. And then, thus, for each $10 decrease in rent, he's renting 15 more units or 15 more apartments or townhouses, etc. So even though he's losing out on $50 in rent per unit, for every $10 he decreases in rent, he's renting out 15 more units. So that's where the more revenue, it's going to increase revenue, because then he's able to rent out more units by dropping the rent and making it more affordable to people. Okay, so I'm going to check for understanding here. We're going to use that same equation from the last example, R of X, and the remainder theorem to find the revenue from the properties if the property manager decreases the rent by $100. So we're using that same function, R of X, from the previous example for the revenue, and we want to know how much revenue is created if the property manager decreases the rent by $100. You have 4 choices, A, B, C, and D. So go ahead, work out the problem, and then select your answer. Okay, so we had the function R of X equals negative 150x squared plus 1,000x plus 480,000. And what we want to know is how much revenue is created from the properties if the property manager decreases the rent by $100. Now remember, for every $10 decrease, the property manager can rent out 15 more units. So we need to figure out how many $10 decreases occur if the rent is decreased by $100. So first of all, $100 divided by 10 means that there's 10 $10 decreases to give you a total of $100 decrease. So we have 10 $10 decreases. If we use 10 as our divisor, and our revenue function has coefficients of negative 150, 1,000, and 480,000. I carry out my synthetic division. We get negative 150. If we multiply that by 10, we get negative 1,500. And if we add that column, 1,000 and negative 1,500, that gives me negative 500. And if I multiply negative 500 times 10, that gives me negative 5,000. So I subtract 5,000 from 480,000, that gives me $475,000. So my answer here should be C, $475,000. That is the amount of revenue that the property manager will create by decreasing rent by $100. Okay, so the factor theorem is the next theorem that we're going to discuss. And in the factor theorem, a polynomial f of x has a factor x minus c if and only if f of c is equal to 0. Now, we've talked about this kind of informally so far. In the very first video, I asked you to factor polynomials all the way after you've completed the long division. And the only way you can factor a polynomial is if your remainder is equal to 0. So that's what the factor theorem is generally saying, is if we have a function f of x that is divided by x minus c and our remainder is 0, that indicates that f of c is equal to 0. Or, if I state it another way, we can say that x minus c is a factor of this polynomial function f of x if and only if, when we divide the function by c, we get 0 as our remainder. So, let's look at an example here. It says use the factor theorem to determine if x minus 5 and x plus 5 are factors of the polynomial x cubed minus 18x squared plus 60x plus 25. Use the binomials that are factors to write a factored form of f of x. Here's the deal. So we'll test x minus 5 first. And if we're going to use synthetic division to see if x minus 5 is a factor of x cubed minus 18x squared plus 60x plus 25, I need to use synthetic division. So first of all, I need to figure out what my divisor for the synthetic division is. And if I set x minus 5, my divisor equal to 0, my divisor then is x equals 5. So I'm going to go ahead and carry out my synthetic division using 5. And my polynomial is x cubed, 1x cubed, so I have a 1, negative 18x squared plus 60x, so I'm going to have 60 next, and then a positive 25. If I carry out synthetic division, I drop down my 1. 1 times 5 is 5. Negative 18 plus 5 is negative 13. Negative 13 times positive 5 is negative 65. Negative 65 plus 60 is negative 5. When I multiply negative 5 times the divisor, which is positive 5, then we get negative 25, and we add the last column and we get 0. So since our remainder here is 0, that tells me that x minus 5 is a factor of this polynomial f of x. Now, what happens is since x minus 5 is a factor, we can then use these coefficients to write the remaining factor. So for instance, this polynomial x cubed minus 18x squared plus 60x plus 25 can be written as x minus 5 times, in parentheses, these numbers right here are the coefficients of the polynomial that is left over. So remember, in synthetic division, the last number is always our remainder. I move one to the left, that's my constant. Then the next term is x, and then x squared. So after I've determined one of the factors here is x minus 5, again because our remainder was 0, then I use 1x squared minus 13x minus 5. I use these coefficients at the bottom to write out the remaining polynomial. Now, what I get then, I have to factor this polynomial that's left. I have x minus 5, and if I factor this, I have to multiply to be negative 5, but add to be negative 13. That polynomial is not factorable because I cannot multiply two numbers to get negative 5 and then have those same two numbers add to be negative 13. So this right here is factored all the way. This is as far as I can factor f of x, the original function they gave me. Now, one of the things that we still have to do is to check to see if x plus 5 is a factor of this function, and I will do that on the next slide. Alright, so one thing I did not do on the last slide is determine if x plus 5 is a factor of f of x. Now, I'm pretty sure already, I'm almost positive actually, that x plus 5 is not a factor because remember that quadratic that I was left with was not factorable at the end. But I'm going to go ahead and show using synthetic division that x plus 5 is not a factor of this function f of x. So if I set my divisor equal to 0, that gives me x equals negative 5. If I use negative 5 as my divisor, my coefficients are 1, negative 18, 60, and 25. Again, those are my coefficients from each term in my polynomial function. And if I carry out synthetic division, I carry down the 1. If I multiply 1 times my divisor, which was negative 5, that gives me negative 5. Negative 18 plus negative 5 is negative 23. Negative 23 times negative 5 is positive 115. 115 plus 60 is going to give me 175. And if I multiply 175 times my divisor of negative 5, let's see, that gives me 175 times 5, 25, carry the 2, 35, plus 2 is 37, carry the 3, 5 times 1 plus 3 is 8. So I get 875 here. And that's going to be negative 875 because, again, the 175 was positive and the 5 was negative, so that my product is going to be negative. And if I have negative 875 plus 25, that gives me a remainder of negative 850. Now remember, in order for x plus 5 to be a factor of f of x, your remainder, when you carry out the synthetic division, has to be 0. And you notice here that our remainder is not equal to 0. Thus, x plus 5 is not a factor of the polynomial. Okay, we're going to use the factor theorem to determine if x minus 5 and x plus 2 are factors of f of x equals x cubed minus 2x squared minus 13x minus 10. We're going to use the binomials that are factors to write a factored form of f of x. So, what we're going to go ahead and do is we're going to start with x minus 5. And if we start with x minus 5 and set it equal to 0, our 0 for that factor, or for that divisor, is x equals 5. So I'm going to go ahead and start by dividing by 5. And my coefficients for my polynomial are 1, -2, -13, and -10. And I need to make sure that I'm not skipping any powers here. We have all our exponents here, 3, 2, 1, and then x to the 0 attached to the 10 here, or -10 for that matter. So we're not skipping over any terms in our polynomial. So we have all coefficients accounted for, 1, -2, -13, and -10. And now I'm going to carry out the synthetic division. So I'm going to carry down the 1 to start. Then I multiply 1 times my divisor. 1 times 5 is 5. If I add this column here, 5 and -2, it gives me a sum of 3. 3 times 5 is 15. 15 times 15 plus -13 gives me a positive 2. And when I multiply 2 times the divisor, which is 5, I get a positive 10. And when I add this column, -10 and positive 10, I get 0. So, my answer to this question is yes, x minus 5 is a factor of this polynomial. This polynomial function f of x, because my remainder is 0. So, if I'm going to write this polynomial function f of x in factored form, so if I'm going to factor x cubed minus 2x squared minus 13x minus 10, my first factor is going to be x minus 5, and then I'm left with x squared plus 3x plus 2. Now you might be wondering where I'm getting these numbers from right here. These numbers are coming from what's left over after I've completed the synthetic division. My coefficients were 1, positive 3, and then my constant was 2. So remember, when you carry out synthetic division, the first number, or the last column is your remainder. Then it's your constant, x to the first, and then here we would have x squared. Now, what we need to do on the next slide is determine if x plus 2 is a factor of this polynomial as well. Now, in order to figure out whether x plus 2 is a factor of that polynomial, we do not have to go all the way back to the coefficients we started out with. Okay, we don't have to go back to the 1, -2, -13, and -10. We can use these coefficients at the bottom that were left over and go ahead and divide those coefficients by a divisor of x plus 2. I will do that on the next slide. Alright, so we're supposed to tell whether x plus 2 is a factor of that function f of x. And like I said on the last slide, we do not have to go back to the coefficients that we started out with. We can use the coefficients that we had left over after we determined that x minus 5 was a factor of the polynomial. So the numbers that were left over were 1, 3, and 2. And my divisor, because x plus 2 is my divisor, in the divisor box I need to calculate what the 0 is for this function. And so the 0 for x plus 2 is x equals -2. So if I put a -2 in my divisor box and I carry down a 1 and multiply 1 times -2, 1 times -2 is -2. 3 plus a -2 is a positive 1. 1 times -2 is also -2. And what do you know? We get a remainder of 0. So our answer is yes, x plus 2 is a factor of f of x. And what I'm going to do then is, since x plus 2 is a factor, and we already determined that x minus 5 is a factor as well on the previous slide, we can say that f of x is equal to x minus 5, which is the factor that we determined on the last slide. We now, on this slide, determined that x plus 2 is a factor because we got a remainder of 0 right here for our synthetic division. And that leaves me with another factor that is generated by these two numbers left over in synthetic division. So my remainder here is 0. My 1 is my constant, and then I also have a coefficient of 1 in front of x. So this leftover factor, the last factor for this polynomial, is 1x plus 1. So the constant right here is 1, and then the coefficient of x is also 1. Now, what would happen if I multiplied these three factors out? Well, it should give me that same polynomial I started out with, f of x. So I'm going to do that just to check my work to make sure my factoring was correct. It should be. I'm going to start by multiplying and FOILing out x minus 5 times x plus 2. If I do that, I get x squared plus 2x minus 5x minus 10. And I'm going to go ahead and multiply that by x plus 1. But before I do that, I can combine like terms here. This negative 5x and 2x really give me a negative 3x. So when I multiply this trinomial, these three terms, by x plus 1, I distribute the x to every term. So that's going to give me x cubed minus 3x squared minus 10x. And since I've distributed x to each of these terms, then I go ahead and distribute a positive 1 to each of the terms, which just gives me x squared minus 3x minus 10. Now, if I combine like terms to simplify, I get x cubed. Negative 3x squared plus x squared is negative 2x squared. Negative 10x and negative 3x is negative 13x. And my only constant is negative 10. So this right here should be the function f of x on the previous slide, written in standard form, right? This is written in standard form. And in factored form, f of x is equal to x minus 5 times x plus 2 times x plus 1. Alright, so it's time to check your understanding. We are going to use the factor theorem to determine if the binomials, remember binomial means two terms, so x plus 2 and x minus 5 are factors of the polynomial function f of x equals 4x cubed minus 9x squared minus 19x plus 30. We're going to use the binomials that are factors to write a factored form of f of x. So you have four choices, A, B, C, and D. A says yes, both factors are, both x plus 2 and x minus 3 are factors, and this is what your polynomial is going to look like when you're done factoring it. Answer B says yes, x plus 2 and x minus 3 are factors, and this is what your polynomial is going to look like when you're done factoring it. And then obviously C says yes to x plus 2, but no to x minus 3, and this is what your polynomial would look like if you factored it. And answer D says no to x plus 2, but yes to x minus 3, and this is what your polynomial would look like when you're done factoring it. So you have four choices here. I want you to go ahead and work out this problem and then submit your answer, either A, B, C, or D. Alright, so we're going to go ahead and walk through the answer. Hopefully you responded to the last question correctly. We're going to check x plus 2 first, which means if I set x plus 2 equal to 0, my divisor is negative 2. I'm going to go ahead and carry out my synthetic division with negative 2 as my divisor. My coefficients from my polynomial function f of x are 4, negative 9, negative 19, and positive 30. I'm going to carry out synthetic division. By carrying down the first term, I get 4. 4 times negative 2 is negative 8. Negative 17. Negative 17 times negative 2 is a positive 34. I'm going to add 34 and negative 19, which gives me positive 15. And when I multiply positive 15 by my divisor of negative 2, that gives me negative 30. And if I add the last column, I get a remainder of 0. So my answer to this portion of the question is that yes, x plus 2 is a factor. X plus 2 is a factor of the polynomial, again, because our remainder is equal to 0. So now what I need to do is check to see if x minus 3 is a factor of f of x, this cubic polynomial. Now remember, if the first factor checks out, I do not need to go back all the way back to these coefficients that we started out with. The 4, the negative 9, the negative 19, and 30. What we can use is these coefficients, but we can only use these coefficients if our first remainder was equal to 0. So I'm going to go ahead and I'm going to carry out to see if x minus 3 is a factor. X minus 3 produces a 0 at x equals 3. So I'm going to put 3 as my divisor, and this time my coefficients are 4, negative 17, and 15. Okay, again, these 4, negative 17, and 15, the only reason I'm able to use them is because our first remainder was equal to 0. So, I'm going to start by carrying down the 4. 4 times 3, 4 times my divisor, which was 3, is 12. If I add my middle column, negative 17 plus 12 is negative 5. And negative 5 times positive 3, my divisor, is negative 15, which again gives me a remainder of 0. So since I got a remainder of 0, that means yes, x minus 3 is a factor of the polynomial f of x. And if we write f of x in a factored form, f of x written in factored form is going to be, one factor is x plus 2, the other factor is x minus 3, and then the last factor comes from these numbers that were left over. Again, this was my remainder, this would be my constant, and this would be the coefficient of x. So I would get a remaining factor of 4x minus 5. Now, if I multiplied these three factors together like I did in the previous example, I should get this polynomial at the top, f of x equals 4x cubed minus 9x squared minus 19x plus 30. So, in terms of your multiple choice answer, the correct response to the multiple choice question was B. Okay, B, our answer for B was yes, yes, both are factors, and then f of x should be written as x plus 2 times x minus 3 times 4x minus 5.